This denotes a sequence with different values of n, and an represents a term in the sequence. So let's do some problems. So we have to determine whether the sequence converges or diverges. So the question will always be whether converges or diverges. So what we have to do is we have to compute limit n going to infinity an. So this limit, if this is infinity, then diverges. Or if some finite constant, then it converges. So this section is then computing this limit n going to infinity. Let's do 31. We have an how to take this limit. So what I have done is I factored out n square from the numerator and n square from the denominator. And this is radical sign, so you have n's. They would cancel out. And as n goes to infinity, 1 over n square goes to 0. So we're left with radical 4 over 1, which is 2. So this means it converges. See. So C would denote converges and D would denote diverges. Let's do one more problem like that. (33). Here AN is now let's first rewrite AN. Let's factor out n cube, which is the highest power of n. So if I factor out n cube from the denominator, like this, so this becomes 1, and you have 4n over n cube. That's a 4 over n squared. And this is a radical sign. That's why we carry a radical sign here. This is 3 halves. Some cancellation here. So now if we take the limit, when n goes to infinity, n square goes to infinity. So 4 over n square will go to 0. This term goes to 0. So then the denominator is 1. But when n goes to infinity, this goes to infinity. So your answer is then infinity. Therefore, this diverges. Let's do next problem. (39). Sine n. So an is sine of n. So what happens when n goes to infinity? So if I just draw sine, so you see sine x is always bounded between 1 and negative 1. 1 and negative 1. 1 and negative 1. So this an never approaches a fixed value. Never a fixed value as n tends to infinity. Because sine function always oscillates between 1 and negative 1, 1 and negative 1, 1 and negative 1. Therefore, the sequence will never approach a fixed value as n goes to infinity. So therefore, we call it divergent. So this means diverges. So this is another criteria for divergence. And there is no fixed value as n goes to infinity. So in addition to being infinity, limit or it oscillates. It's instead of oscillate, let's say not a fixed value. That also implies divergence. Like in this example. So next problem. Very important. (43). So this type of problem is an example of what we will see, very important, squeeze theorem. Very important. And what do we mean by squeeze theorem? So this is cos square. Cos square is bounded by 1 from above, and it's always greater than 0. Because of square, you have 0 to 1. If it was just cos, then you will have negative 1 to 1. Okay, then what does it mean? You can have 0, divide everything by 2 to the n. So then this side is just 0. Here we have our an. And this is 1 over 2 to the n. So we have 0. Or to write it more clearly, we have this side is 0 because there is no n, it's already 0. Here, as n goes to infinity, 2 to the n goes to infinity. So this 1 over 2 to the n this goes to 1 over infinity. So this will be 0. This limit goes to 0. So we can say so we have squeezed this between two zeros. This is what we mean by squeezing. Between zeros. Therefore, this means it converges. By squeeze theorem. So this is very important, adding this step. So all these steps. Very important step, important step, important step, and then important step, writing the squeeze theorem. Let's do next problem. Forty 5. N times sine 1 over n. So first rewrite it in this form. I'm just taking n into the denominator, therefore it's 1 over n. Because when the denominator has 1 over n, it means n is a numerator. And I'm writing this to make the argument, because argument of sine is 1 over n. Now let's look at this. Let's call f of x as sine 1 over x or 1 over x. Now what happens when x goes to infinity? As x goes to infinity, sine, this argument goes to 0, because it's 1 over infinity. Sine 0 is 0. X goes to infinity, 1 over infinity is 0. So this is an indeterminate form of 0 over 0. So when such a thing happens, we can apply L'Hopital's rule. We can apply so if we do that, so this is the symbol for it. This symbol means I'm applying L'Hopital rule. Derivative of numerator, just cos, and then chain rule. Over derivative of denominator, which is 1 over x. This will cancel out. So as x goes to infinity, 1 over x goes to 0. And 1 over x goes to 0, cos 0 is 1. Because this is finite, now since f of n is a n, right? I'm now just changing back to n from x. From x, I'm changing back to n. So limit which is 1. Therefore, it converges. So this is just a proper way of converting from n to x. We'll do one more problem. Number 47. So we will approach it in the same manner. Or let y denotes left. So changing n to x. Then if I take the log of both the sides, natural log, which means that's the property of log. The exponent comes after. Okay. Then if we take the limit x tends to infinity ln y. So we are taking the limit of ln y. Now this is an indeterminate form because x goes to infinity, 2 over x goes to 0, ln 1 is 0. This is an indeterminate form of type. So we cannot apply L'Hopital rule yet. So we have to change it into other type. Yes. So I'm bringing this x into the denominator. That's why 1 over x. So now this is the indeterminate form of type 0 over 0. That's x goes to infinity, 1 over x goes to 0. 2 over x goes to 0, and 1 plus 2 over x goes to 1, ln 1 is 0. So now you can apply L'Hopital rule. So this is now so what do we get? Only when it's 0 over 0 or infinity we can apply L'Hopital. Derivative of ln 1 over plus 2 over x. Chain rule. Right. And then derivative of 1 over x. This is 1. Derivative of 1 over x is negative 1 over x squared. Derivative of ln of 1 plus 2x, 1 over function and the chain. So this will cancel out here. We're left with this minus and 2 over x goes to 0 as x goes to infinity. So it's 2. But we are not done yet. So what we have shown is limit x tends to infinity, ln y is 2. This is limit for ln y, but we want for y. Therefore, y is e to the power. So now by previous argument, an is y of n. Just replace x with n. So limit n tends to infinity, an equals limit tends to infinity plus e square. So therefore, and then converges. So these are some important problems from 11.1.